This here is my latest project, a meter that can measure almost anything, and this without the need of any sensors. Are you curious about how this works? Then watch the video all the way through. Well, let us begin with the VFD tubes. For my taste, these are fascinating parts because they are closely related to Magic Eye tubes and CRTs. As with these, the segments are covered with a phosphor that emits light when hit by electrons from a filament, which is also the cathode of the tube. And the segments are the anodes. Each of these is connected to one of the leads coming out of the bottom of the tube. 7 segments plus decimal point make 8 terminals, so the pattern to be shown on the tube can easily be represented by 1 byte. These byte patterns come from an ESP32, where they are defined in a lookup table and sent over 2 wires using the I2C protocol. This is then decoded by an I2C decoder chip. Its 8 output pins switch the 30-volt anode voltages via a transistor array driver. For not having to build this circuit for each tube, a trick comes into play: multiplexing. Let's have a look at the tubes again. Did you notice the grid between the filament and the segments? A positive voltage on the grid speeds up the electrons on the way to the segments, while ground potential cuts their way off. By this way we can enable or disable the whole tube. A 4017 decade counter and another array of transistors cycle them one by one, with each tube showing its own pattern. Because of the inertia of the eyes, it looks like all the tubes are showing their pattern at the same time. By the way, did I already mention the programmable RGB LEDs beneath the tubes? These give a cozy color accent and also serve as status indicators. And here I'd like to thank PCBWay for sponsoring this video. PCBWay made these high-quality circuit boards for this project. On their order page, the circuit boards are highly customizable, so why not give them a different solder mask color than the usual green? Over time, PCBWay has become my preferred PCB manufacturer. The boards are always finished and delivered within a few days, and they always work perfectly without any problems. Soldering them is easy and fun. I made a design for 4, 6 or 8 tubes. That's why they have these cutouts that make it easy to cut them into 2 or 3 pieces. Put the pieces together like this, or like so. It depends on how many tubes you have. A 7-segment display like this is perfect for displaying numbers. However, when it comes to displaying letters, we quickly realize that 7 segments are just not enough to do the job properly. A possible solution is using the IU4 tube instead. This has 16 segments but is smaller and also rare and therefore harder to get. I didn't buy them because I still had 6 of the IU11 in my hobby box. As a trade-off, I'm using an alphabet for 7-segment displays. Looks modest, but you can at least decipher it. So the meter can also display simple text for menus or units, for example. As mentioned before, an ESP32 is the microcontroller that controls it all. And the whole device itself can be controlled by a rotary encoder. A boost converter module steps up the 5-volt supply voltage to around 30-volt anode voltage for the tubes. Here I solder a wire to the enable pin of its IC. This way the ESP32 can take control of it. To make it an eye-catcher, I crafted a wooden box where it fits in perfectly. Okay, at least with a bit of force. And it is of course important to bring power to it. I use an USB cable from which I cut off the device connector, so I can power it from any USB port or power supply. It's important to mention that the power supply must be rated for 1 amp at least. And finally I secure it with a cable tie. Not to forget the rotary encoder, which goes to the right. At last I covered it with a brass metal sheet that I also got from PCBWay. In addition to PCBs, PCBWay also offers CNC machining, 3D printing, injection molding and sheet metal fabrication. They offer a good choice of different metals and finishes. So I ordered a sandblasted brass plate. And again, the quality and precision is absolutely stunning. Notice how precious it looks with this tray. Contrary to what you might have expected, I didn't connect any sensors to the ESP32, nor did I put in any contacts to connect any. Well, the all-in-one meter works completely wireless. The meter gets all the data to display through so-called REST APIs, where REST API stands for Representational State Transfer Application Programmer Interface. This works with HTTP requests issued over an IP network. Without wasting any time on details, the URL starts with your hostname, followed by the endpoint that represents a specific function call on the server, and after the question mark come the parameters as key value pairs. All the meter does is to send this request to an HTTP server with REST API and display the server response on its tubes. A second ESP32 with connected sensors can take the role of a server there. But let me show you another approach. There are many public REST APIs available on the internet. On GitHub you can find a good selection of such APIs sorted by topic. Many of these require authentication, which means that you have to register with the service and, in most cases, pay some money. So I will focus on these which are free of charge. Here is a free API that returns Chuck Norris facts. Clicking on its link takes us to a website where we can find its documentation. The Chuck Norris API has an endpoint that takes a query string as a parameter. When I type this into the address bar of the browser with horse as a query term, the API returns some Chuck Norris facts about horses. Of course, the reply does not show up as a nice web page. Instead, you get a messy JSON string like this. Fortunately, the Firefox browser can render JSON, so we can see how the data is structured.
Chuck Norris recently won the World Horseshoe Pitching Tournament while they were still attached to a Clydesdale.
This makes it easy to analyze the response before implementing the application. My application is the all-in-one meter, but with 6-7 segment tubes it's a bit difficult to display whole sentences. For sure, Chuck Norris would have painted the extra segments with noctilucent radium paint. Anyway, I need to find an API that returns numeric values. So I came across the API of OpenMeteor.com. This returns weather data from the past hours and days, but we are only interested in the current values. So all the ESP32 has to do is isolate the desired values from the JSON string and send them to the tubes. In the configuration file, the locations of the values of interest in the JSON response are defined and also how to display them. For the OpenMeteor API, it's stuff like temperature, wind speed, direction and so on. But there are other API queries defined too. To select one of the queries on the meter, we press a knob and turn it until the alias of the query we want appears on the display. When we let go of it, it sends the API request and the LEDs turn yellow until it gets the response. Turning the knob without keeping it pressed cycles through the items. Another query I want to mention here is the current time and date. These are retrieved from the ESP's local web server. This gets a time via NTP on startup. And here is one that returns the exchange rate for Bitcoin, so we will never miss out a good trade.
Yes. Bogdanov, he did it. He bought. He went to all in. Dump it.
The query named Sense is interesting, because it gives you access to environment data all around the world. Of course, this includes any kind of weather data. All this data is captured by the Sense boxes. Sense boxes are mainly run by enthusiasts and those who like to tinker with IoT devices. The boxes send the collected data to a cloud over the internet or LoRaWAN. They come as a kit with waterproof case and a pre-assembled PCB where sensors can be easily plugged in. Originally intended as an educational project for schools in Germany, Sense boxes can now be found all over the world on OpenSenseMap.org. Let's pick one randomly. Okay, one in Switzerland. Greetings go to the guy with a Swiss accent. There is some owner-supplied info about the box, sometimes a nice picture. And below that is the data it offers. To make this box available to my meter, I copy its ID from the address line and paste it into the URL in the config file. Ctrl left click opens the URL in the browser so I can check if everything works like expected. Then we need to adapt the items in the config file to the structure of the JSON response. Can also add a new item there, the illumination level for example. The last thing to do is to flash the config file into the SPI flash file system of the ESP. I wrote a batch file for this. That's it. So if there is a sense box in your neighborhood, the all-in-one meter turns into a weather station. Pressing the control knob twice within 1 second takes you to control mode. There we can change the color of the LEDs and their brightness. And it can also control other IoT devices if they provide a REST API. Here I have a LED bulb that I flashed with Tasmota. And so the meter became a dimmer for a light bulb. This makes the all-in-one meter a great platform for all kinds of IoT and home automation projects. Write a comment if you have any project ideas for this device in mind. I hope you liked the video, so please give it a thumbs up. Also subscribe and enable notifications to be always up to date. And consider supporting my work via Patreon or channel membership. See you in my next video.